All right, section 9.3. We're going to take a look at the parabola. And remember, we've already studied the parabola in the class. In fact, we kind of already looked at two forms of an equation for our parabola. Here is the standard form. We call this one, the first one here, y equals a times the quantity x minus k plus h. And then we also looked at our parabola, in this case a quadratic written in descending order, ax squared plus bx plus c. And in these situations, in our first situation here, the vertex of our parabola is kh. And in either case, either of these forms, the parabola opens up if a is greater than 0 and opens down if a is less than 0. And if we have it here in our descending order, y equals ax squared plus bx plus c, then the x-coordinate of the vertex is x equals b over negative 2a. So remember, b over negative 2a, and then we could find the y-coordinate of that by just taking f of whatever that x-coordinate is, and that would give us our y-coordinate to find the vertex of the parabola. What we're going to do today is look at another way of working with a parabola, another way to graph, another way to think about this, and that's looking at the parabola again with the vertex that we're familiar with that, but here are some new things for us: the focus and the directrix. And so I've got a parabola here now, and this parabola is, instead of opening up and down, we're also going to be looking at parabolas that open left and right today. And the directrix is just this line behind the parabola. The focus, like we've worked with foci before in this class, the focus is just a little bit up from the vertex. Again, we have an axis of symmetry here. We've already familiar with that from last time. So what we're going to do today is we're going to look at graphing parabola using the focus, directrix, and another thing called the latus rectum. So here's kind of another way to define a parabola, and the way this defines it is very similar to the way that we define an ellipse and a hyperbola. And that is, a parabola is the set of all points in a plane that are equidistant from the directrix and the focus. So if we look up here at our parabola that I have graphed, here's our directrix, again the line behind the parabola, and then our focus, sorry, line behind the parabola here, and then our focus just a little bit up from the vertex of the parabola. And basically what this definition is telling us is that all the points along this parabola, those points are equidistant from the focus and the directrix. So if I take this point right here, d1, the distance going now perpendicular to the directrix here, going in a perpendicular line, this distance to the point is the same as the distance from the focus of the parabola out to that point. And if we look anywhere, along this parabola, those distances will be the same. Here again, here's d1 and here's d2. Notice they've both gotten a little bit smaller, but the distances are still equal here. And so all of the places, all of these points on here are going to be equidistant from the focus and the directrix, and all of those points then give us this parabola. So this is another way to think about a parabola. Let's see, a couple other things to notice about the focus and the directrix. If this d1 and d2 are the same everywhere, when we take a look here going across the vertex, the distance from the vertex to the focus and the distance from the vertex to the directrix are going to be the same. And this little piece of information is going to really help us graph these items, that this distance and this distance are the same. Because basically, if you have the vertex and you know where the directrix is, then you know this distance and this distance have to be the same, so you kind of automatically get the focus for free there. So anyways, that piece of information is going to help us graph. Okay, so now we're going to look at the standard forms of the parabola, just like we had standard forms for the ellipse and the hyperbola. Okay, we're going to take a look now at the standard forms of the parabola. So just like we had standard forms for both the ellipse and the hyperbola, we're going to have standard forms of the parabola. We're going to have two of them here because our parabolas can be opening left and right now. and that's if we have this form, y squared equals 4px. It's going to open to the right if this 4px value is positive. It will open to the left if this 4px value is negative. And here's another thing to note here. P sub 0 is the focus. We're also going to use P to find the directrix here. In fact, P is going to be a very valuable quantity here for graphing parabolas in these two standard forms. So one of the first things we try to do in any of these equations is figure out the value of P. And that's why you see it listed in the equation here. So again, right if this is positive, left if this is negative. Now we're also going to have parabolas that open up and down. And so when we're in that form, where x squared equals 4py, if this 4py value is positive, we're going to be opening up. If it's negative, we'll be opening down. And just like with our left and right values, it's going to be really critical here to find the value of P. All right, let's take a look here at question 1. We want to find the focus and directrix of this parabola here. Y squared is equal to 8x. Well, we know this is going to be opening to the right because it's a y squared problem and we have a positive value over here. In order to find the focus and directrix, we're going to need to find the value of P. So if you look up here, we're kind of in this form, y squared equals 4px. To find P, what I need to do is just factor a 4 out of that coefficient. So I'm going to factor a 4 out here. So let's see. So I'd have y squared is equal to 4 times 2x. Once we get it in that form now, it's going to be easy to see that the value of P is 2, because we're in the form y squared equals 4px. Well, right there's my P value. Once I have P, now I can find the focus and I can find the directrix very easily. So let's look at a sketch of this. Okay, looking at a sketch of this. I don't have any shifts going on here. Y squared equals 8x. If there were going to be shifts here, I'd have, y plus 2 or y minus 2 or maybe an x plus 2 or an x minus 3 or something like that. These are no shifts. So basically, this vertex of this parabola is going to be centered right at the origin. So there's the vertex of my parabola. Now, we know this is opening left and right, so I'm going to be traveling from the vertex now left and right. In fact, I'm going to be traveling from the vertex a value of P left and right to find my focus and to find my directrix. So we already decided over here that the value of P was 2. So we know that P is equal to 2. Now, P is this distance that we're going to travel from the vertex out to the focus. So my focus is going to be 2 units to the right here. My directrix is going to be equidistant going the other way, so 2 units to the left. 1, 2 units to the left. Here's my directrix. And remember, the directrix is a line. So it's the line here, x equals -2. So now I know that my parabola is opening to the right. I know here is my focus. I know here is my directrix. And I know that these distances, the distance between this distance between my vertex, which is a point on the parabola, out to the focus, is the same as the distance from the vertex, the point on the parabola, out to this directrix. Now, everywhere else on this parabola, we're also going to be equidistant here. It'll be all of these points, like if I had a point here, that would also be equidistant from the directrix line and the focus. The only thing left, if I was going to sketch this parabola now, the only thing I really have left to figure out is how wide this parabola opens. Is it a narrow, skinny parabola that's coming up like this, or is it real wide, or somewhere in the middle? To figure out the width kind of our parabola here, we use what's called the latus rectum. So let's take a look at that now. Okay, so the latus rectum is the distance, or kind of how wide the parabola opens, and we measure this as a line that goes right through our focus. So this line is going right through our focus, and it tells us how wide the parabola is going to be. Okay, and so the distance, let me scroll down here just a little bit. The distance of the latus rectum is the absolute value of 4p. So the overall distance from here to here is 4p. So let's go back to our problem we were sketching up here before. So the distance across the latus rectum is 4p. Well, we know the p-value is 2. That means the distance across the latus rectum here is going to be 8. So if I come to my focus here, I want to go an overall distance of 8, which means I want to start here and go up 4 and down 4. So if I start here and go up 4, 1, 2, 3, 4, there would be a point on my parabola. Start here, go down 4, 1, 2, 3, 4. There's another point on my parabola. That's how wide this parabola is going to open. All right, let's take a look at a question here. Question 2, I want to sketch the graph of x squared equals negative 12y by finding the focus, directrix, and latus rectum. So notice this is an x squared equals some number. So this is going to be opening up or down. What you want to do here is find p. Once you find p, you can find the focus, the directrix, and the latus rectum and sketch a graph. So go ahead and pause your video player now and sketch a graph of this parabola. When you're done, hit play to see how you did. Okay, in order to sketch this graph using the focus, directrix, and latus rectum, the first thing I'm going to have to do is figure out the value of p. So what I want to do is I want to come up to my equation here, and I want to factor a 4 out of here. That will help me figure out what p is. So let's look at my equation now. X squared equals 4 times negative 3y. So this tells me then that my p-value is negative 3. Okay, that's going to help me now find the focus, directrix, and latus rectum. Notice if I look back at my graph here, there are no shifts. I don't have an x minus or plus anything, a y minus or plus anything. So I know the vertex of my parabola is going to be right at the origin. Okay, p is negative 3. This is an x squared parabola, so that means it's opening up or down. Since p is negative, this thing is going to open down because that's telling me now that the focus is going to be down from my vertex negative 3 units. So 1, 2, 3. Here's the focus. Now since the focus is on this side of my vertex, I know that if I go up 3, 1, 2, 3, this will be the directrix line. So I'll draw my directrix line in there. So I know my parabola is starting at the vertex. I know it's opening down. The only thing left to find is how wide this parabola is going to be, and so that's the latus rectum. And so the latus rectum here is, remember, the absolute value of 4p. So in this case, right there, if I take p as negative 3, 4 times p is going to give me negative 12. I take the absolute value of that. It's going to be positive 12. So notice that the latus rectum is always just this absolute value of this coefficient that we have out front here. So the overall distance this parabola is going to open around the focus is 12, which means I want to go 6 in each direction. So 6 to the right, 1, 2, 3, 4, 5, 6. 6 to the left, 1, 2, 3, 4, 5, 6. That's how wide my parabola is opening. Now I can go ahead and draw a sketch of it. All right, let's take a look at question 3. Find the standard form of the parabola with focus at 8, 0 and the directrix at the line x equals negative 8. So we're kind of shifting gears here a little bit now. Before we were looking at equations and graphing them. Now we're going to kind of look at some information about the graph and write the equation. So go ahead and pause your video player here and see if you can answer this question. I've given us a little coordinate plane here so we can sketch some information on it. I think the key here, again, just like when we were graphing, take an equation to graphing, is to figure out what p is. So if we find the value of p, we should be able to get everything else about this now equation for this parabola. So go ahead and pause your video player and answer this question, and when you get done, hit play to see how you did. All right, let's take a look. So we know that the focus is at the point 8, 0. So I'm going to come out to 8, 0 and draw the point of my focus. 1, 2, 3, 4, 5, 6, 7, 8. There's my focus. I know that my directrix line is at x equals negative 8. So coming over here, 1, 2, 3, 4, 5, 6, 7, 8. Here's the line of my directrix. Okay, So this tells me, if this is my focus and this is my directrix, this is telling me that first the vertex of this parabola has to be halfway between these 2 points. Well, we came out here 8, we went over there 8, so the vertex is going to be centered at the origin. So I know that I won't have any shifts in this graph. Centered at the origin. I also know that my parabola is going to open away from my directrix line. So I know this guy is opening to the right. Let's go ahead and try to figure out what P is. Well, P is just this distance that we're traveling from the vertex out to the focus and also out to the directrix. It'll always be that way. This distance here is going to be P units, same as this distance there is going to be P units. So in this case, P is equal to 8. And remember, so this parabola now is opening to the right. So that's a y squared parabola. And if it's opening to the right, we know it's positive. We also know it's positive because P was positive. The distance we traveled from the vertex out to our focus was a positive direction. That tells us our equation is going to be positive. So let's look at our standard form here. It's going to be y squared is equal to 4px. It's kind of the standard form of a parabola opening to the right. I know that P is 8, so I'm just going to plug that right in there. And so I'll get that y squared is equal to 32x. And there's the equation of this parabola opening to the right. All right, let's take a look at question 4 now. Sketch the graph of x minus 2 quantity squared is equal to 4 times y plus 1. And again, we're going to graph this using our focus, directrix, and latus rectum. So you can see here now we've got some shifts going on. So shift here, shift there. This is the same way we've shifted things before, so I think you're going to be okay with that. Again, the thing we're going to want to find is P, but I think that's going to be pretty easy to find here. So go ahead and pause your video player now and sketch a graph of this equation, and when you're done, hit play to see how you did. All right, let's take a look now. So first thing we want to do now is let's find the vertex. So let's find the vertex here. The vertex, the shifts are going to be opposite of what they seem. So since this was x minus 2, that's going to be a positive 2. Since this was y plus 1, that's going to be a negative 1 shift there. So let's come over here and graph a vertex over 2, down 1. Okay. Now let's take a look kind of at the general form. The general form here is this is kind of an x squared equals 4py equation. So this is a positive situation. So this is going to be opening up. If this was negative, it would be opening down. But since it's positive here, we're going to open up. Since this is just 4 here, it's telling me that P is equal to 1. So let's come back to our vertex now. We know it's going to open upwards, so I'm coming back to my vertex. I'm going to go up 1 unit. There's my focus. Down 1 unit. There's going to be my directrix. Had we had a negative value here, we would have traveled from our vertex down to the focus, and this parabola would have been opening downward. But since my form here was positive, I start at the vertex and travel up to the focus. So I know that this is my vertex and my parabola is opening up. The only thing I need to do now is figure out how wide it needs to be. So I look at the latus rectum, which again is the absolute value of 4p. Well, we know p is 1, so here the latus rectum is going to be a distance of 4. So I come up to my focus, the overall distance is 4, that means I'm going 2 units in each direction. So 1, 2 here, and 1, 2 here. Now I know how wide my parabola is going to be, so I'm ready to sketch it. Alright, let's take a look at question 5 here. Graph y squared plus 2y plus 12x minus 23 equals 0. So again, this is a situation that we've dealt with both the ellipse and the hyperbola. We've given us just this equation. It's not organized. At this point, we don't know whether this thing would be an ellipse, a hyperbola, or a parabola. Obviously, since we're working with parabolas here, that's what it's going to end up being. But we want to organize it now. So we want to organize it kind of in this form, you know, we want to get it in standard form here. We want to get it to look like this guy right here. So notice in this form we've got all of our x terms on one side, all of our y terms on the other, and one of them ends up being a nice perfect square, and the other one ends up being something y plus 2, y minus 1, something like that. Now this could be switched. We don't know if this graph that we're looking at is an x squared graph or a y squared graph. So let's go back to this guy. But we do want to get it organized. So go ahead and pause your video player now and see if you can get this thing organized. We want to have perfect squares, at least on one side. And then we're going to try to factor something out of the other. So go ahead and try to organize this thing. If you get it organized, go ahead and sketch a graph. When you get done, hit play to see how you did. Alright, so I'm looking at this thing and I know this is going to be a y squared graph of some sort because I'm starting over here with y squared. So this thing is going to be either opening left or right. I want to get all my x terms to the other side, and I want to have this a perfect square. So let's see, if I do y squared plus 2y plus some mystery number is equal to negative 12x plus 23. Now let's figure out what value I need here to make this a perfect square. Well, leading coefficient of 1, so my c term is going to be 1/2 of b squared. Well, 1/2 of 2 is 1. If I square it, it's going to be 1. So this is going to be y plus 1 squared. Now notice I increased the left side by 1 when I added that value there, so I better increase the right side by 1 as well. So let's see, I have negative 12x plus now 24. Alright, I'm getting closer, but I need to kind of see what shift is going on here with x, and I also need to figure out what's going to kind of come out front. So that leaves me now factoring these two terms, if possible. And in this case, it is possible. So it looks like I could factor a negative 12 out of each of those terms. So that's what I'm going to do. And I'm going to get x minus 2. Once I get here, you can see now this equation is set up and organized for me to graph it. I've got my y shift here. I've got my x shift here. I know it's a y squared graph. And it looks like I could find my p-value, and it also looks like my p-value here is going to be negative. So let's see. Let's take a look at what p is. Remember, it's 4px in this case, so p is going to be negative 3. Once I've got p and I've got the location of my vertex here, I can sketch this graph. So my vertex is going to be coordinates of 2, positive 2 in the x, and negative 1 in the y. So let's come over here, ready to sketch this graph. Positive 2, negative 1, there's my vertex. Now I know this guy is opening left and right. P is negative, so that tells me that my focus now is going to be to the left of this. Negative 3, 1, 2, 3. There's my focus. That tells me my parabola is opening to the left here. My directrix is going to be on the other side, the same number of units, p units. 1, 2, 3. Let's try that again. 1, 2, 3. There's my directrix line. Okay. Now I just need to figure out how wide it's going to be opening here at the focus. And so I'm going to find the latus rectum, which is again the absolute value of 4p. So that's just going to be positive 12. So positive 12, that means it's going to be 6 units in each direction. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Ready to sketch my parabola. Okay, that should give you enough information now to go ahead and start your My Math Lab homework. If you have any questions, shoot me an email. Have a great day.